So hello and welcome to Tech Day 2015, our breakout event on sheet metal. Don't be a dumb solid. So this is a breakout event that we did at our Tech Day 2015 events, where we took about 3,000 different technical support calls regarding sheet metal, collected them, and found out what are the common issues, what are the common challenges. And this presentation is a collection of those to help make sure that everyone is aware of these best practices to make you more efficient when you get into the sheet metal tools. So I'll give you my death by PowerPoint slide here. There's a lot of information that I have to cover. I am going to go through this pretty quickly. So if you're watching the recording, feel free to pause, rewind. But if you're watching this live, take a look for the recording so that you can catch up on some of these details if this goes a little bit too fast for you. So let's just start out with the best approach. What are we taking a look at with sheet metal? I mean, often I do have customers that send me files that the part looks like a sheet metal part, but guess what? It's not. They use regular boss extrude, cut extrude features to make a part look like sheet metal. But did you know there are actual sheet metal features inside SolidWorks? And if you're going to create a sheet metal part, use those sheet metal features. So this is your base flange, your edge flange, miter flange, etc. You see the command manager toolbar up there at the top of SolidWorks by default. Use those tools. If you're maybe bringing in imported geometry, maybe it was a sheet metal part created in a different CAD system. This is a great application where you can use the insert bends feature, where it'll recognize the bends, give you that nice flat pattern. Of course, in some cases, you may be trying to think, well, if I'm trying to create a sheet metal part and I don't know exactly how I'm going to do it using the standard sheet metal features, you might be able to create the envelope, the shape, or the volume of that sheet metal part using the traditional features in SolidWorks, your boss extrudes, cuts, etc. Well, to create that volume, you can then use the Convert to Sheet Metal option and select those external faces to enclose that solid volume that you've created. So in order of approach here, again, best practice, use those sheet metal features. Those are going to give you the most robust sheet metal part. And if you've been using sheet metal for a while, you've seen some evolution to our tools. So if you're using SolidWorks 2013 or later, your feature manager, your feature tree should look something like this. If you don't have that sheet metal folder, you don't have the flat pattern folder, when you create a new sheet metal part, you need to recreate your template. Make sure that it does have these folders. If it doesn't, you can potentially see some issues in your sheet metal part and the behavior, especially when you get into multi-bodies. And there's a couple things that I do want to point out there. So in your feature tree, like I mentioned, you should have a sheet metal folder, flat pattern folder. And a couple things of interest here is when you create a sheet metal part, that sheet metal feature does have properties associated to it. But guess what? So does that parent folder. So I'll touch on this a little bit later here, but again, this is what helps manage these properties so that when you create a feature, it's going to be created as you would expect. Now, a couple things, a couple system options to cover. Verification on rebuild. If you've done any surface modeling, you may have gotten into this tool to make sure that it's on. But if you are using sheet metal and you don't have this option on, please turn it on. This does something called advanced body checking, and let me just show you an example of the trouble that you could get into if you don't have this option on. Take a look at this part. Notice I do have a fillet applied to it, but what's going on there? The fillet was created after the shell, so if I look on the inside, well, it looks like a sharp edge. On the outside, you see that fillet, but I also see that inside face. So this is because with advanced body checking off, when you create a feature, it's only comparing that feature, that fillet, to the neighboring faces. Well, guess what? To create that fillet, all those neighboring faces are fine. When you turn on advanced body checking, or verification on rebuild, it's comparing it to all of the faces. So which would compare it to that inside edge and realize, hey, there's some invalid geometry here, there's a problem. So again, go into your system options, performance, verification on rebuild. So now when I do a Control Q, force rebuild the part, it recognizes the issue, brings up fillet expert. So maybe we should create that fillet before the shell to properly create this part. So again, this is important to have on with sheet metal, just so that the features that are creating, it is comparing it to all the faces in the body. Make sure we're not creating any invalid geometry. Again, if you're doing anything with surfaces, highly recommend turning this option on as well. Keep in mind that if you have this option off and you upgrade a version of a file from, say, 2014 to 2015, the first time it rebuilds in 2015, it will do that rebuild with verification. So if you open up a part and there's a bunch of rebuild errors because of this advanced body checking, it's because it was not on the first time that part was created. So when we create holes, remove some material to create room for flanges, there's a critical option here that we want to make sure that is on, and that is the normal cut option. Now, so a couple tools that do not have this option are the hole wizard and simple hole. So ideally you're using cut extrude to create or to remove any geometry in your sheet metal part. And again, keep this enabled unless you have a specific reason to have it disabled. I got some questions on the hole wizard, especially with PEM holes. Again, this is an excellent example of where you may need to use the hole wizard to create those standard holes. But again, normal cut is not an option. I typically don't see an issue there, but again, generally, you want to have that normal cut option on. Because if it is off, this is where a couple challenges can come up in your sheet metal part. So taking a look at this simple part, do you notice any issues? Sure, our flange on the right-hand side has our reliefs, but flange on the left-hand side does not. And sure enough, when we flatten this, yeah, we get a rebuild error. So if I come back to that extruded cut, I turn on normal cut, now I get the proper reliefs. So again, that's just a simple case of where it's critical to have that normal cut option on. Make sure that the sheet metal features are able to evaluate correctly. So if you caught the rebuild error that came up in the last part, it gave me a message like this, right? The part self-intersects. This part intersects itself. This can result in some strange behavior in your sheet metal part. It can cause simplistic errors and also cause issues with downstream features failing to be created. So this is something that we need to resolve if you're seeing this. So let me open up another part that shows this example. So sure enough, right when I open it, it's letting me know that the part self-intersects. And this is because I have a zero gap between these two flanges. On the last part, it was because my flange, when it flattened, it was merging with the rest of the body. Again, this is an issue that we need to correct. Well, how do we correct it? We just need to add a very small gap. So with a case like this, we'll just add a very, very, very small offset. Something that's negligible for manufacturing, but again, critical for SolidWorks. So now that I have that small gap, from this view, it really doesn't look any different. Guess what? We can flatten the part out, no problem. So again, if you run into this issue, run into this rebuild error, create a very small gap. Again, negligible for sheet metal parts for manufacturing, but critical for SolidWorks. And it's important to do this in the same feature, or create the gap before the feature is created. So here's another example. And since you've made it about 11 minutes into the presentation, I've got a great sheet metal joke for you. So what do you call a stack of flat patterns like you see here? Well, of course, it's a pile of sheet. So let's take a look at how we can make this into a valuable sheet metal part. So again, we get intersection, rebuild errors. And this is a nice flat pattern that you can generate if you really want to. So how can we overcome this issue? Well, in this example, we already have the material removed. We need to edit the flange profile. And again, we're just going to move this in here. We can add dimensions as necessary just to create that small gap. And that eliminates the issue. Of course, a very small gap, negligible for manufacturing, critical for SolidWorks. So another option there, if you do create this feature, maybe it was on the top, you can actually use the offset into a reverse offset to bring it down further, and that will trim away the sides and give you a valuable part. So I mentioned earlier it's critical to make sure you address the self-intersection in that same feature or prior to that feature creation. So think of it designing from the flat, right? Every feature must need to have proper reliefs, and they need to belong to the same feature that is creating it. So don't create them after, right? If you're familiar with that SolidWorks feature tree, you know it's rebuilding this model from the top down. So we want to remove any instances of that self-intersection at the time that feature is created or before. Do not go in and trim extra geometry away after. And I'll clarify that with do not go in and remove the self-intersecting geometry after the self-intersection has already happened. So let me give you an example there. Now in this case, we do have an instance of self-intersection with this little sliver. If I roll back here just to show you how this part was created, we have a flange on the left with a rectangular relief, flange on the right with a tear. Now we have this little sliver. So sometimes what I see here is some folks will come in, create a cut extrude, and eliminate that sliver. Well, sure, that looks fine, but again, that's not the best practice. So instead, what would be ideal here is we'll edit this flange. Now, optionally, we would use a different relief type. So I could just switch over and choose the extend option, and that'll work well here. Or you can just bring in another rectangular relief to cut out the extra material. But as you can see here, there's still this little couple jogs here in the face. Now is where we can go in and add the feature to clean that up. Again, so make those modifications to the geometry during the edge flange creation of the sheet metal feature or before it's created to eliminate any of those instances of self-intersection. Again, we're rebuilding this from the top down. We want to make sure we have a healthy model. So one of the advantages of sheet metal, of course, is calculating the flat pattern. So SolidWorks has a built-in algorithm that just finds the smallest area to fit that flat pattern. So sometimes it's not the most effective, right? Some of you may have run into an instance like this where our flat pattern is rotated compared to the grain direction of the material. And if we take a look at the properties here, we take a look at that bounding box area, and this has again been automatically calculated to find the smallest bounding box area. In this case, we want that bounding box vertical in line with these edges and specify that grain direction. So this is where we can go in, edit the flat pattern feature, specify a grain direction by picking a model edge, and then rotate our bounding box. So if we go back into our properties, we can see our updated bounding box. We have a nice part with the orientation that we want to keep. Regarding mirror features, especially mirroring sheet metal features, if at all possible, just to keep things simple, easy, and efficient with SolidWorks sheet metal, use mirror body whenever possible. So you can pick for your mirror plane, pick the thickness of the face that you want to mirror the body over. And of course, you can mirror over individual sheet metal features, feature by feature, but again, it's going to be more efficient, more robust to do mirror body when possible. But again, if you do have to mirror feature by feature, you can do so, and that's fine. The recommendation, though, is to validate the flat pattern after you mirror each feature. Make sure it is coming out as expected to help validate your model so that you can double check yourself as you go along rather than doing a whole bunch of work and then doing a flat pattern to find you have an issue. Do some of this validation as you go along to prevent any issues with the model. So with SolidWorks, we have a couple new features and enhanced features, especially with 2015, with our swept flange options. Let me show you an example of that and a couple different ways, the options associated to generating that flat pattern. And I got to mention here, the help does a very good job at getting into details here that I'm going to exclude here for this presentation. So refer to the SolidWorks help there. It really makes it easy. So I have a couple examples here, a couple form sheet metal parts. We can utilize the swept flange feature where we give it a profile and guess what? A path. So this is where we can actually flatten the geometry along that path, that curved path, but guess what? That can give us a flat pattern like so. Not exactly what we want. So this is where we can edit the geometry, turn off that flatten along path to get perhaps a better flat pattern. Let's take a look at another example. So again, with that flatten along path on, we can generate these curved profiles, these curved flat patterns, compared to with that option off, getting us a flat sheet. So again, what's going to be the best option here for you really depends on how you're going to manufacture it. So one thing I do want to mention regarding this feature, and this is new with 2015, it's called Surface Flatten, and it's available with SolidWorks Premium. So what we can do with an example like this works great for your compound bends or formed sheet metal parts. We can use the new Surface Flatten feature to pick the surfaces that we want to flatten. And keep in mind, this works for really anything except in addition to sheet metal. So we'll select the faces that we want to flatten, the surfaces, select a point to flatten about, and any control curves, so the geometry that we know that's going to maintain its length. This creates a surface for us, so we can isolate that and generate perhaps a better flat pattern for the design. Also with this gives us a deformation plot to understand how much stretch or compression is necessary to take this flat pattern and form it. So what about these other advanced sheet metal features? We have lofted bend conditions and some nice enhancements with 2015 where sketches don't have to be parallel. Also with the bent condition, we no longer require filleted corners. And there's an option here, refer to endpoint, that I want to explore with you. So with a loft, right, we need two profiles. And with this bent condition, the profiles do not need to have the filleted corners. So what happens here is we are given faceting options where we can specify chord tolerance, number of bends. As you can see my preview update as I make changes here, and we can drive this based on segment length or segment angle. And here's the option I was mentioning earlier, refer to endpoint. Take a look at the end condition here, what's happening in the corner. If we turn that option off, it smooths that out. So of course this does have an impact on our flat pattern. But one of the powerful features here is this does give us our bend lines. And one of the requirements here, if you do want bend lines here in these sheet metal parts, those sketches, the profile sketches do need to be parallel. But let's take a look at that other option here for formed. In the formed condition, right, sketches don't have to have the equal number of linear and nonlinear segments, and they don't have to be parallel. But again, if you do want bend lines, they must be parallel, and you do need to have an equal number of linear and nonlinear segments. So let me show you a case where I don't have an equal number. So in this case, we do have a circular arc, 3 straight lines that are filleted in the corners. Great application for our formed sheet metal. I just have to put in a quick note here for our message. This provides great details, so if you do run any issues, the profile is not building as expected, take a look at the message. Also, the help is a great resource for you. But here with that formed option, we can generate that sheet metal part, we can generate the flat pattern, but guess what? What do we not have here? Bend lines. Of course, in this case, this was because the number of segments in my sketches were not equal. All right, so for drawings, when you create a drawing of a flat pattern sheet metal part, it's going to create a derived configuration in that part. So a couple critical things. Make sure that you have right access to that sheet metal part, especially the first time that drawing view is created. It's automatically creating a derived configuration, making a change to the part. You need to be able to save that part. Otherwise, guess what? That configuration will be lost. It wasn't saved, so the next time you open up your drawing, your sheet metal flat pattern will be folded because it doesn't have a flat pattern configuration to work with. Also, if you do need to reconfigure the orientation of that flat pattern view, you can edit the flat pattern in the part and specify your desired fixed face. Regarding sketched bends and reliefs, so one of the critical calculations here, if you go in and use the sketch bend feature, make sure that the distance of that line from the body of the sheet metal is greater than or equal to the part thickness plus the bend radius. Let me show you a quick example where we did not follow those rules. And this is what you can end up with, right? Extra geometry from the sheet metal part that is getting bent. Well, if we take a look at our sheet metal feature, our thickness is 3 millimeters. Our bend radius is 3. So what should our offset distance be for our sketch bend? It should be at least 6, but it's 5. So I can come in here and make that change to 6, exit the sketch, rebuild. Now that sketch bend looks much better. One of the powerful features here with drawings is if you need to reuse any of those annotations or custom properties associated to that sheet metal part, such as the bounding box, cutting length, bends, allowance, material, mass, you have quick access to this information by right-clicking on that sheet metal drawing view, going to Annotations, and choosing Cutlist Properties. This will give you a note out of the box from SolidWorks that contains all of this information. Of course, if you remember earlier, I was talking about verification on rebuild, how critical it is to have it on, but is it required? Is it absolutely required? Well, no, it's not. Again, highly recommended though, but in cases where I would recommend where you turn it off is if you have a very, very complex sheet metal part. And with that complexity comes a lot of rebuild time, a lot of calculation time. So for cases like this, you can turn off verification on rebuild, make your modifications, and then before you save and go home for the day, go back into your options, turn verification on rebuild back on, do a Control Q, make sure the part is nice and happy, then save and close it. Now, one thing to help out here is you can use feature freeze. Once you've built the features with verification rebuild on, you can freeze them. But one thing to note about feature freeze is it is not compatible with the flat pattern feature. So you can freeze up to a certain point, but not the entire sheet metal part. So in regards to performance, here's another case where it takes longer time than perhaps expected to generate a flat pattern part. And that's typically when you have a lot of cuts going through bends. So taking a look at this bent sheet metal part here, getting us our flat pattern. Yes, well, we can do this in SolidWorks now, just as simply as you may imagine. It takes some time to calculate that flat pattern feature. So instead, we can create a more efficient model where in the folded state, we suppress the feature, the pattern feature, we flatten it, go into that specific configuration, and in that configuration, we will recreate the linear pattern features and suppress them for the folded features. So that's what you see on the right hand side is we've suppressed, for our flattened state, we've suppressed the linear pattern feature and recreated them in the flattened state. So as you may know, any features created after the flat pattern feature stay in the flat pattern feature. So a couple other options. Typically, you don't have to worry about this one unless you're using earlier versions of SolidWorks, because in 2013, this multi-body flat pattern feature is grayed out. It's always on. But if you're using 2012 or earlier, make sure you have this option enabled in the document properties. So again, keep in mind, this one is specific to the sheet metal document. A couple other things of note in regarding our flat pattern is we can simplify bends. So this will linearize the bends. So you can see the before and after comparison here. And this option does not apply to unfold. So typically I get this question, right, when we're generating the flat pattern, exporting it to a DWG DXF, do you want that bend to be curved or not? This is where you can linearize it with simplified bends. And when we're generating that flat pattern, a couple things that you may be checking is the bend allowance, bend deduction, etc. There's a default option here, and that is merge faces. So by default, you would end up with a flat pattern like you would see here on the left-hand side. Well, if you want to verify each individual flattened segment, turn that option off so that then you can select the edge and calculate the length so that you can validate that bend allowance, deduction, etc. And associated with this bend allowance, you can edit this to avoid issues like you see on screen, where we have a lot of material here in a bend, but when we generate the flat pattern, it may be very small. So this is where it's important to make sure you have the proper arc length specified for that bend deduction. And keep in mind with this, for these bend allowance control options, they're located in multiple locations. In your sheet metal folder, in the sheet metal feature, and in these individual bend features or sheet metal features. So if you make a change in one location, it doesn't apply to all your features, go back in, check these other locations, or in many cases, make sure that you're using the default options here that would be specified in that sheet metal folder. So again, right click on the sheet metal folder, edit feature to define these default options. Regarding form tools, one quick note, make sure that the radius of curvature in the form tool is less than the thickness of the part. So if you go to your tools menu in SolidWorks, go to check geometry, one of the results from there is giving you the minimum radius of curvature in that forming tool. So where you can validate that forming tool prior to use it and then running into this issue. SolidWorks does do a good job though. If you do a form tool that doesn't work, it tells you, lets you know that curvature may be an issue. If you have any questions, feel free to send it into support. And this is, again, a common thing with bend tables. If you are in doubt, you don't understand what's going on, send it into support. However, 90% of these issues are coming from the bend table being in an invalid format. So take a look at the out-of-the-box bend tables from SolidWorks and modify those to specify your desired criteria. Also, another common issue is that the thickness falls outside the thickness of the bend table. So this is where setting up proper configuration in your sheet metal parts in the beginning can save a lot of time downstream avoiding these issues. So I really appreciate your attention today. Thank you for coming to our Tech Day webinar on sheet metal. Don't be a dumb solid. So hopefully you can keep those sheet metal features smart. Have a great day.